we're going to look at different ways of expressing domain and range for discrete data. You'll remember that the example with Jorge represented a discrete relation because there were no meaningful values between the dots on our graph. Right? We plotted the ordered pairs on our graph, and we didn't connect them because it didn't make sense to. It didn't make sense to say that we could measure Jorge's distance after 2.65 jumps. That doesn't make any sense, right? We measure it at 0 jumps and 1 jump and 2 jumps and 3 jumps and 4 jumps, and that's it. Nothing in between. Okay? So there are different ways of describing domain and range for discrete data. There's 3 ways actually, and we're going to look at how to do that. Okay? To keep things simple, we're going to say that Jorge can only jump 7 times before he gets tired and has to go and take a nap. Okay? Frogs can't jump all day, especially championship frogs like Jorge who jump 2 meters at a time, which is pretty impressive. All right. So one way that we can represent our domain and range is with words. Excuse me, with words. We can just write a sentence to explain the types of numbers that our domain and range can be. Okay? So let's think about the domain first. The domain. Remember, the domain is talking about the independent variables. The independent variable, n, the number of jumps. What kind of numbers could that be? Well, in this case, n, or the number of jumps, can be any whole number from, well, what's the lowest it could be? It could be 0 all the way up to 7. All right, any whole number from 0 to 7. Right? So he could jump 0 times, 1 time, 2 times, 3 times, 4, 5, 6, up to 7, and then he takes a nap. So those are all the possible values that n can be. Now let's think about the range. How far Jorge can go, right? Well, if the maximum number of jumps that he can take is 7, then what's the furthest he'll jump? Well, just really quickly here, 2 times 7, that's 14. 14 is the highest he can go. Okay? So we could say the distance Jorge jumps is a whole number from 0 to 14. Okay, and that encapsulates all the possible values that our dependent variable can be. In this case, d. All right? Let's move on to another method. Number lines. These are a little simpler. Okay? All we do here is we just put a dot on the values on the number line which each variable can be. So the domain represents n, that's the number of jumps, and we think what numbers n could be. Well, it could be 0, 1, 2, 3, 4, 5, 6, and 7. So let's just put some dots on those numbers there. So it could be 0, maybe I'll use red, hang on. Okay, so 0, 1, 2, 3, 4, 5, 6, and 7, and that's it. Right? He can jump 0 times, 1 time, 2 times, 3 times, all the way up to 7. What about the range? Well, he could go 0 meters. If he jumped once, he'd go 2 meters. If he jumped again, he'd go 4 meters. Jumped again, he'd go 6, 8, 10, 12, or 14. There we go. There's our domain and range represented with a number line. The last way we'll try to represent domain and range is with a list or set notation, and this is something that's going to be new to you. It's pretty simple to do for discrete data, but it can be initially complicated for continuous data, but hopefully that won't go too bad when we get there. But discrete data, it's pretty simple to do this. What we're going to do is we're going to list all the values that each variable can be inside of a pair of something called set brackets. They look like this. Okay? These are set brackets. And a set in math is just a group of numbers. Okay? A group of numbers that have some kind of meaning or some kind of a relationship to each other. And we use these special brackets to show that they belong together. Okay? So we're going to show the domain in set brackets, and then we're going to show the range. So let me just write here, domain. Okay, so it's going to be in a set bracket here. What numbers could the domain be? Well, as we've identified before in the last two representations, it could be 0, 1, 2, 3, 4, 5, 6, 7, and with a set bracket. Okay? The way we say this in math is we say this is the set of values 0, 1, 2, 3, 4, 5, 6, 7. Okay? It's just a list of numbers that the independent variable n can be. The range is represented in the same way. The range is represented as 0, then 2, 4, 6, 8, 10, 12, 14. It's very important that you use these set brackets. I know they can be difficult to draw at first, but don't use these brackets. Okay? Those brackets are used for something called sequence, and they're a little bit different than sets. Okay? I'm not going to explain what sequences are. Maybe if you ask me when I get back, I'll let you know. But make sure you use these brackets when you're using a list or set notation. That's very important. Okay?